Hello everyone, welcome back to chapter 10 part 3. In this part we'll continue with the short run cubic production function estimation. So I'm going back one slide and this is what we covered at the end of part 2. So this is a summary of short run cubic production function. I'm just going over it so that we remember. Total product short run cubic production function looks like this, and because of this shape what you'll see is labor. So you'll see total product to have this S shape. We're gonna see very soon. Average product, marginal product, we learned how to calculate these in part 2, and diminishing marginal returns and diminishing average product sets in at these points of labor. And we also have these parameters estimate restrictions. I want A to be a negative number, B to be a positive number. So in this part we are actually going to study that. This is a scatter diagram for a cubic production function. As you can see, it is S-shaped, okay? And then you will see that diminishing marginal product sets in around 20 workers, and average product starts diminishing about 29 workers, okay? So because of this cubic production function that looks like this, cubic name comes from the third power, and it does have this beautiful S shape, nice expected average product curve, yeah, and marginal product curve, and also quantity has this beautiful looking convex isoquant. Okay, so let's talk about estimation of a short-run production function. In this part, we are definitely getting our hands dirty. We're going to estimate a production function. So to use linear regression analysis, right, we have a problem if we have this production function. You have to transform cubic equation to linear form. You can't estimate anything. Remember, y equals a plus bx. It can't be y over 2 equals a plus b 1 over x. This is non-linear. Non-linear in x, non-linear in y. So here we have non-linear, this cubic production function, non-linear in x's, okay, L raised to the power 3 2. So what we do, it's very easy. You're going to transform it to we're going to call L raised to the power 3x, and we're going to call a squared as w. Okay, we're going to do this simple transformation to be able to use regression to estimate my production function. Estimated regression also must pass through the origin. I'm going one slide back. Look, production function starts from 0. So if you have 0 labor, you want your output to be 0. So you can't produce with no labor, okay? Which means we want our production function to pass from the origin. So if you look at a regular regression, a plus bx, right? So like this yx. So a was the intercept. I want my intercept to be forced to pass through the origin. So I want this little a to be 0, in other words. So we need that restriction too. Keep that in mind. And regression through the origin is a regression in which the intercept term is forced to equal to 0. That's what we want. We are going to estimate this using data for which the level of usage of one or more inputs is fixed. So capital is fixed, right? And time series data is usually appropriate. However, it needs to be short enough period so that capital is not changing. What does that mean? Let's say I am the CEO of General Motors. Okay, we don't really add factories every month. Let's say for 2 years we did not open factories. Actually, GM announced all electric factory in January 24th of 2022. It's a random, news. But what I'm trying to say is that when it happens, it's in the news, okay? So assume that capital is fixed, so no factories are being added, so on and so forth. So we're going to estimate the following short-run production function. Q equals a L raised to the power 3, B L raised to the power 2. Average product we calculated before. We divided everything by L, right? A L raised to the power 2, BL. Marginal product, again, first derivative of this production function with respect to labor. And we also found the points at which diminishing marginal returns and diminishing average products sets in. We want to find these points. So we're going to estimate this equation using a simple linear regression model where x is L raised to the power 3 and w is L raised to the power 2. So if you estimate this regression, these are the results you get, right? And what is A here? A is the parameter estimate is of L raised to the power 3, so negative 0.0047. What is B? It's the parameter estimate of the coefficient estimate of the L2, 0.2731. Okay, that's nice. So if we write the production function, it looks like this. And if you want to write average product, it's going to be A, negative 0.0047, right? L raised to the power 2 plus B, 0.273 L. Marginal product is going to be, you can write this down, 3A, 3 times negative 0.0047 L raised to the power 2 plus 2B, 2 times 0.2731. I just grab B, L. Okay, what is LM? That's also easy. Negative B, B is here, 0.2731 divided by 3 times, what is my A? Negative 0.0047. You can calculate all these, or I'm going to calculate them in a second. And this is negative B, 0.27, negative 0.2731 divided by 2 times, let's put one more parenthesis here, 2 times negative 0.0047. So you can calculate them manually, very easy. And I'm going to now actually estimate this equation and generate everything in Excel, which is going to help a lot. So let's do this. So we are now on Excel. All right. Okay, what do we have? I already have this data input. So go to Excel file chapter 10, table 10A. I posted. There's data input tab. You're going to see this file, observations 1 through 40. Okay, then we have labor column, then we have quantity column, then I created L3 and L2. What are we doing? We're going to regress quantity, which we have here, on L raised to the power 3, L raised to the power 2. I only have L, therefore I must create, what I'm going to do, I'm going to find L raised to the power 3. So equal sign, choose this cell, raised to the power 3. It's a head, 3, enter. I'm going to click on this cell, go to the right bottom corner till I find this black cross. Boom, pull it all the way down. This is L raised to the power 3. Next, L raised to the power 2. Okay, I just create these values. Okay, next I'm actually going to run regression. This is the most fun part. We're at home, go to data, data analysis. Okay, click on that. You're going to see regression. This is something we always do. Click, right? Input Y range. Y is my quantity. Choose it with the label 2. Click on label. Don't forget to click on label. And then next, we're going to click on input X range. Okay, I'm going all the way up. Input X range, then choose these 2 columns, L3 and L2. One more thing we have to do, click on this little box. It says constant is 0. Constant is 0 means their intercept is 0. And okay, so I got the results. So my results are interesting. They're a little bit different than the book. This is what publisher sent me. This data is what publisher sent me. So if there's little bit deviations because of maybe they use slightly different numbers, I don't know, but that's what they sent me. I emailed them today actually. So it's okay, the numbers are close enough. The intercept is 0 because we forced it to be. Let's take a look at other stuff. Okay, So R square is really, really high. That's a good sign. Okay. And my F statistic is really high. Significance, this is a really small number. It's like 0.0032 zeros, then 176. Okay, this is really statistically significant. And A is the coefficient estimate of L3, which is negative. That's what we wanted. Is it statistically significant? So I'm going to look at p-values. P-values are shown as 1.42 E minus 6 zeros. Okay, I'm going to format these cells, make it number, and really put lots of decimal places. As you can see, L3, this is really significant. It's less than 1%. This is like even less than. It's a really, really highly significant level. B is also statistically significant, and it's positive as expected. So what I'm going to do, data input, I'm going to actually grab these that I prepared in the previous one, and I'm going to paste them here. I just pasted them. So what is my A? A is the coefficient estimate here. I'm just replicating what is my B, coefficient estimate FL2. Okay, so I can plug in values of L, LM, LA. I can calculate LM. What was the formula of LM? LM was negative B divided by, open parentheses, 3 times, right, A. So LM is 20.61. This is close to the number from our example, but it's not exactly the same due to the fact that I'm given little different numbers by the publishers. Let's calculate LA. It's going to be negative B divided by, open parentheses, 2 times A, close parentheses. Okay, 30.92. So diminishing marginal product sets in around 20 units. Diminishing average product sets in. Next, I'm actually going to write down the equation for Q. Okay, so I am going to put A, right? So A, what I will do is I'm going to put dollar signs to fix the formula. If I copy paste, it doesn't actually go anywhere. L raised to the power 3, I'm going to grab this cell, which I will input L there in the future. L raised to the power, power 3 plus, okay, so it's going to be B, I7. I'm going to put dollar signs before letter and number to fix that, times L raised to the power, so let's also fix L. Let's put in L, and then I'm going to put dollar signs raised to the power 2. So that is going to be my quantity depending on what L I plug in here. I plug in 10, 22.46. Okay, so I'm just getting a dynamic formula for Q. So what is average product? Average product, I'm going to just go here. Average product formula is A times L raised to the power 2, B times L. So I'm going to copy this quantity, okay? What I'm going to do, I'm just going to edit this formula. So A, L raised to the power 2, so instead of 3, I'm going to put 2, and B, L only, okay? B8. All right, so that's average product. Let's calculate marginal product. So 3AL raised to the power 2. So I'm going to copy, paste here. However, I'm going to adjust it. Okay. 3 times AL. So I'm going to do 3 times AL raised to the power 2 plus 2 times AL itself. Okay, so we should be good. Enter. All right, So you can basically enter whatever number you want here and get the results for your quantity, average product, and marginal product. So let's see if we enter L. Boom, you have, if you hire 10 people, this is what it means in English. If you hire 10 people, you're going to produce 22 units. Average product is going to be 2.2 units. So the on an average labor contributes 2.2. The last worker contributes 4 units. So what if I do this equal to LM? Boom. If you hire 20.6 people, which is the point after which the marginal product starts declining, you're going to produce 75 units. Average product is going to be 3.6. On an average, laborers produce 3.6, and the last worker produces 5.52. If I hire 21, my margin product will be less than 5.52. So it has gone down. If I hire 30 people, 4.38 as we expected. So what if I equalize labor to the maximum point of average product? Average product and marginal product are equal to each other at the maximum point of average product. And we are producing 128 units when we hire 30 people. So this is just very simple example of how you can calculate everything, right? Plugging, let's say 300, if I hire 300 people, output becomes actually scary a little bit, right? So 10 people hired, 22 is being produced. This is dynamic. You can make this table. Actually, you can create these values for a range of values. You can plug in, right? I can plug in L here. I can create L0, 1, 2, 3, and pull this down up to, I don't know, all the way. Okay. Then you can, this is so cool. What you can do is that you can put quantity here. You can put quantity, and I'm just going to copy this formula because I fixed everything. The formula will work. So control copy. Let's do paste formula, not the number. Okay. So this is my formula, and I want L to be taken from here. So I'm going to, instead of doing I8, I'm going to, instead of doing I8 here, I'm going to grab this labor column. Okay, check this out. This is so cool. So I'm going to put average product here, and I'm going to put marginal product here. Okay, so okay, average product. So again, I8, instead of I8, I'm taking this value. Okay. All right, that is correct now. So average product, I'm grabbing, what I'm going to do, I'm going to copy this formula, paste it formula, okay? And then instead of taking labor L from here, I'm going to tell the formula to grab this. And I'm not done. There's one more labor here that needs to be adjusted. Grab this one, please. Okay, check this out. And let's calculate marginal product. So I'm going to copy this formula, paste this formula here. Okay, so I'm going to again adjust I8. Whenever I see I8, I'm simply going to put this one. And there's another I8 here. We're putting this one. Okay, and I'm going to pull this down. So check this out. Isn't this super cool? Okay, I'm going to stop at this level when the total output. So if you hire 62 people, you're actually going to start producing negative levels of output. All right, I don't know why it went all the way down here, but let's draw these curves. Why not? So let's draw them. You can draw average product. So you can, let's draw total product first. We're going to the insert charts, scatter. Okay, it actually grabbed automatically, but I want only quantity. So my quantity, this is my total product. Look, it's S-shaped at first, but there is a level in the short run that you hired so many people, your output starts going down. This actually would happen. For instance, you own a restaurant and you hired 2,000 servers to work at a restaurant at a time. That is crazy. Okay, insert. So let's draw the other one, scatter. So I'm actually going to move, where's my scatter chart? It didn't like it. So I'm going to choose this one, labor. Let's do it right. Control. I'm choosing these. Okay. So we're going to do insert, scatter, boom. Okay, as you can see, this is so pretty. Average product and marginal product curves. Table. I'm going to save this as worked. All right, as you can see, you can either manually fill this up and or you can estimate a whole range of values in the Excel function. In the next part, we are tackling cost function estimation. I'll see you in the next part.